one of the things we're going to talk about is the variability or the spread of your set of data values here. So a couple different things we talk about when we discuss spread. You can either talk about the variance or the standard deviation. Okay, and so that's what we've got going on with these formulas here. The first one here, the sigma squared or the S squared, both of these are going to be a variance. And then just the sigma or the S, that is your standard deviation. And then do you guys remember what's the difference between sigma or S? Sigmas for population, yeah. So these are if you have the whole population. Remember it was called a parameter. So then what was S? Sample, and what do we call it? Instead of parameter. Statistic, yes, obviously. From a sample, and they are a statistic, okay? I'm going to show you just a very simple one to find the standard deviation, but you're not going to have to do it by hand on anything that you're doing. Your calculator is going to find it for you. So first, let's do this little example. So you've got 4 friends at wing night. We're eating quite a few wings there, okay. So the typical amount of wings eaten, what do you think we're looking for there? The average. Could you guys find the average here? What do we get? 25. Okay. All right, so even though that's the average, did everybody in the group eat 25 wings? No. Okay. So that's what we're talking about when we say variation. You've got this average, but how far from the average are your data values? Okay. So we're actually going to go through this formula right here. We only have 4 numbers, so it will not be too terrible. What this means, you've got square root, which you know what square root is. The sigma means summation, so you're going to add up all of these values. And then the x minus mu quantity squared, that just means each data value minus the average, and then the square of that total. Okay. Over n minus 1, do you remember what n was? Your sample size. So how many people were in our little sample here? 4, so our n minus 1 would be 3. Okay, so let me just write out for you what this is going to look like. So we're finding S. So the first number was 27. So I'm going to do 27 minus 25 squared. Plus the next person was 23 minus that average of 25 squared. Plus 29 minus 25 squared plus 21 minus 25 squared. That is all divided by our 4 minus 1. And then it's the square root of all of that. Do you guys see why you wouldn't want to do this by hand with, you know, our 91 people in our other little dot plot? Would you really want to find the standard deviation by hand? Let me move it up a little so you guys can see better. So go ahead and calculate for me what S is. And then we'll go through how you're actually going to do this on the calculator. Okay. you guys getting for S? Okay, and you can give me a decimal. We're getting something like 3.65. Yes, okay. 3.65. That is the standard deviation for our sample. Okay. So that's just talking about the variability between what people are actually eating and what the average number of wings was. Okay. So smaller standard deviation, you have less variability in your data. Okay. All right, so let's look at it on your calculator now. So go ahead and go to Stat. We are going to edit a list. All right, so let's go to list 1 again. If you guys arrow to the top and push clear and then enter, that will clear list 1. Do not push delete because then you no longer have an L1. It's gone. Okay, so only clear. Clear your values. So my list 1 is empty. What do you think I want to put in my list 1? Yeah, so those 4 values. So 27, 23, 29, and 21. All right, clearly the list I had here, this frequency list, has nothing to do with this, right? Okay. It's fine if it's still there. We don't need it right now, but that's okay to leave it. All right, so let's go back to our stat. Arrow over to calc. Once you are on calc, we want to do 1-bar stats. Okay, this is one variable statistics. So go ahead and select that. All right, our data's in list 1, right? And do we have a frequency list this time? Nope. Okay, so you can just leave that blank. Arrow down to calculate. Push enter. All right, what does it look like we have here? Everything you need, yes. So X bar, that's our mean, right? Okay. Do you see the 3.65 here? The S, X, that's your standard deviation of your sample, okay? The sigma, that's talking about of the population. So we're definitely sticking with the S right here. It gives you N, the number of terms. If you keep going, it will give you your 5-number summary there. So it gives you your minimum, your maximum, Q1, Q3, all of that good stuff. So one variable statistics is going to give you all of that information you need. Again, you're not going to do this stuff by hand. Your calculator is going to do it for you. Okay? So bring that calculator in. Questions so far? I know that's a really basic one, but does that give you an idea of what we're actually talking about when we look at standard deviation? Okay. All right. Well, let's keep going. So our range here. We're talking about range. That is just maximum minus the minimum. My bad. So in this case, what is the range equal, or how would I go about doing that? Do we have our max and min? Yeah. What's our max? 29 minus our minimum, 21. So we have a range of 8. Okay. Anybody know what IQR, interquartile range, is? Go ahead, Sam. Yes, Q3 minus Q1. Sorry. So if you look back at your 1-bar stat, which is our Q3, 28. Okay, what was our Q1? 22. So we have an interquartile range of 6. The IQR comes into play when we start talking about outliers, how we actually calculate what is an outlier. You can make a rough estimate of, oh, that looks like a pretty extreme value, but there's actually a formula for finding what is considered to be an outlier. Okay. All right, questions over anything on this page? Yes.
So what is the population just defined, whereas the sample is one for finding the standard deviation?
It has to do with the fact that you actually know every single person that you're looking at in a population versus a sample. It isn't the exact thing. You're looking at a piece of it. So that's why it ends up being n minus 1. You will see a lot more of that as we keep going. So for today, it's kind of a, okay, it's n minus 1. You'll see how it plays into it when we get a little further in. Okay? All right. Anything else, guys? Let's keep going. All right, shape. So just a couple notes at the top here, some things that you are looking for. You're looking for major peaks. Not minor ups and downs. So you can talk about the shape where it appears, you know, you're going to cover a lot of things with shape. You're going to cover what the range is looking like. Are there two modes happening? Where's the median? All of those things. So you're going to see some different things with the shape, the skew, how that affects the mean and median, all of that stuff. Okay. You also need to look for clusters, which are clusters, just a whole bunch of data values really close together. Obvious gaps. Outliers. Any sort of symmetry. Or skewness. That's a word. So let's draw some pictures for some of these different shapes that we can talk about. All right, so a symmetric graph. Symmetric graph is going to be roughly the same on both sides. You could fold it in half and everything would match up. So you may have a histogram that is symmetric. Okay. You could have a dot plot that looks symmetric. You can see it in the box and whisper plot. You know, when the left and the right side are very balanced. If it is symmetric, the mean equals the median. What do you think it's going to look like if it's uniform? Yeah, so like let's say you have a histogram again. They just all the same. Okay. Technically, that's also still symmetric, right? You can fold it in half and the two sides would match up. And then the skew ones. If it says skew right. That means the tail goes to the right. Tail to the right. Or if we had a histogram, it might look. You guys see how that's not symmetric anymore? Okay. Skew to the right, your tail is going towards the right. So let's think about our mean and median in this. It says the mean will be greater than the median because it's less resistant to outliers. So think about it. If I have, a really high value out here, do you guys see how that averaged in would bring up the mean? Does that make sense? Okay. So wherever the tail goes, it's going to pull the mean that direction. So if I labeled them on here, it'd probably be like your median would be here. And your mean would be further. Okay, so the mean gets pulled with the tail. So the average is where it would balance. You could put this, on your finger and try to make it balance. That's what it does. Okay, so skew left, what's that going to look like? Yeah, so it's the same thing, but over to the other side. Tail to the left. We'll do it with a dot plot this time. Histogram better. I'm getting rid of the dot plot. And guys, most of the problems you're going to deal with are real world data set. Do you think it's going to be perfect and really pretty data? No. Okay, like this even. This one's a little higher, this one's a little lower. You should expect things like that in the data sets that you guys are looking at. So since we're skewed left, where's the mean going this time? The left. This outlier over here that is bringing down your mean. Okay, so the mean is to the left of your median. Somewhere in there is your mean. And there's your median. All right, bimodal or multimodal. You know what a mode is, right? What is mode? Most frequent. So what do you think bimodal is? No, it means you have two modes. Like you've got two different, like in your histogram, two different bars that have the most values in them. Multimodal, which is kind of hard to say, it's got multiple peaks going on, okay? So if we draw a bimodal one, which is two peaks, your two peaks here, they may not be the exact same height, so it may not truly have two modes. But if you're describing the shape of this graph, you would definitely want to note that there are two peaks in the shape of your distribution. Okay? And then multi would just be there's more than two. As many as shows up in the distribution. Questions so far? We're almost there, guys. And it's almost lunch. So the last thing you want to describe are any unusual features. So we've talked about outliers. You have a very good general idea of what an outlier is. We'll do an actual definition of it here. So it's values that are extremely different from the typical values. So your typical range is normally Q1 minus 1.5 times your IQR and Q3 plus 1.5 times the IQR. So what's IQR again? Interquartile range, that's from Q1 to Q3. Box and whisker plot, it is the box, okay? So we're saying if you go to that Q3 and add 1.5 times the width of the box, that's the typical range. Anything beyond that is going to be too large of a value, it's going to be an outlier. Same thing going to the left. Go to Q1 and go 1.5 times to the left, 1.5 times the size of that box to the left. Anything below that is an outlier. Bell's going to ring soon for lunch, so after lunch we'll actually look at that with some values. So we'll pause there. We're almost done with your Unit 1 notes. What do you think a gap is? What would it look like in like a histogram or a dot plot or anything like that? Yeah, exactly. Like you're going along and you've got like your little pieces of your histogram, and then there just isn't one for a set of values, and then it continues with that. Okay. So it's a value or range of values with no data points. Okay, that makes sense. That's a gap. All right, so then a cluster is just when there's a lot of data points clustered together, okay? So it's a value or range of values. With a noticeably large proportion of data points. Do you think your distribution can have a gap and a cluster? Yes. Yeah, you just need to make sure you describe what is happening and where it is happening. A lot of what you're doing in here is not mathematical in the sense of numbers the way you guys are used to dealing with them. It's all being able to describe things and have context with your description. Right? Being able to say what is happening in a display of data. Did you guys want an example of an outlier with values? Yeah, okay, let's just do one real quick on your calculator. So let's put in some values to 4, 5, 6, 6, 9, and 27. Okay. You're going to do these, you'll be faster at it than me doing it. So put this in your list one for me. We'll practice that. We need to know what our Q1 equals and what our Q3 equals. Remember where to find those? What's it called? Let's try, guys. Where do we find all of these helpful statistics? What do we do now that we have the data? Yeah, 1 bar stack. So go ahead and calculate 1 bar stack. If you do not know how to find that on your calculator, like you forgot, just raise your hand and let me help you. Stat, arrow over to calc, 1 bar stack. Okay? So, I don't have mine in front of me. What is the Q1? 4. And what is the Q3? Okay. What does that make the IQR equal to then? 5, right? That's the difference between Q1 and Q3, so your IQR is 5. Okay. So, to find an outlier, you've got your Q1, and then if we go 1.5 IQRs below that, so minus 1.5 times your IQR, that's going to give you an outlier for your Q3 plus 1.5 times the IQR. All right, your Q1 was 4 minus 1.5 times 5. We don't have any values that are going to be smaller than that, right? Okay, so we don't have any outliers on the left. But what about on the right? It would be 9, 1.5 times 5. This is basically giving us what our max, an expected max would be. What do we get for that? 16.5. Do we have any values above 16.5? Yes. 27 is an outlier. You could have probably guessed that just looking at these data points and like, okay, yeah, that one's a whole lot bigger than the others. But mathematically, that's exactly how you find what the expected min and max are, and then anything outside of that is going to be an outlier. Okay? All right, guys, questions so far? Okay, go ahead, and you've got one more page in your packet. It looks like this. So what we're going to do for the rest of today is we're going to work on these practice exercises. I'm also going to pass out your data journal so that you guys can start those, and I'll explain what I would like to see with your data journals. We've now covered the notes that are relevant to the homework problems, so you guys have your textbook problems you can start working on at home. None of that is due next time, okay? Class after that, we'll start looking at everything, okay? All right, so remember when you are describing your distribution, you need to think about that every single time. You need to talk about all of those. What does the C stand for? Center. What is U? Okay, maybe we need to, let's go through this again. All right, so C is for center. Okay, so we've got our different measures of center that you could talk about. All right. What is U? Unusual features. That's what we just covered. That's outliers, gaps, clusters, okay? What if there aren't any of those? What if there's nothing unusual about it? What should you do?
Which is you should conclude that that's unusual.
No. What should you tell me? What? Yes, actually state there are no unusual features of whatever your data values are that you're talking about. It's none. Tell me. Okay, so don't just skip over it and go, oh, there weren't any, so I didn't talk about it. Always talk about all of them. Okay? And then my two S's. Shape and spread. All right, so I'm going to let you practice with those on the practice exercises, and then we'll talk about it in more detail with exactly what I'm looking for. Let me get your data journals out, and then I'll show you what I'm looking for with that as well. You guys see the advanced degrees thing that it's asking you to look for? Okay. So that now to read it. I can pull up for this. Yeah, if you're not doing it, you can come on. That one is graded. You graded this class. So that's going to help with that this morning. This is my next one. Okay. All right, guys, the data journals, let me just talk about those real quick.